So my presentation is on ocean acidification. Ocean acidification refers to a reduction in the pH of the ocean over an extended period of time, caused primarily by uptake of carbon dioxide, aka CO2, from the atmosphere. How shellfish is being affected is that the ocean acidification has these type of osteoporosis-like effects on shellfish, which means like this kind of bone decaying effect on shellfish, mainly on their shells, which makes it really hard for the shellfish to build or maintain shells. And decrease in the carbonate ions can make building and maintaining shells and other calcium carbonate structures difficult for classifying organisms. So I had this video that relates to ocean acidification and the chemical reactions.
Hi, it's Paul Anderson. I'm sure you're familiar with global warming, how increases in the amount of carbon dioxide is warming the planet, but you may not be familiar with global warming's evil twin, ocean acidification. The cause is the same, increases in the amount of carbon dioxide, but the mechanism is different. Let me show you a demonstration. This is regular distilled water, and I'm going to use a pH meter to measure the pH of regular H2O, and it's going to be right around 7. Now I'm going to take that same distilled water, we're going to put it in a bottle, and we're going to add carbon dioxide to it. We're using a soda stream machine to shoot carbon dioxide in it. It's now just carbonated water. We're going to put it in a glass, and we're going to measure the pH now. I want you to make a prediction of what you think the pH might be. You could even use your finger and point on the screen to where the pH scale is going to be. Let's see how you did. The pH is going to be 3.6. It's really acidic. Let me show you what's going on. So if we take carbon dioxide and water and mix them together, we get carbonic acid. Now that can quickly dissociate and form bicarbonate. What we're doing here is we're losing one of these hydrogen ions, and that can dissociate again and we can form carbonate. We're losing two of these hydrogen ions. Now, if we look at the definition for what pH is, pH, remember, is the negative log of the hydrogen ion concentration. What does that mean? The more of this H plus that we have in solution, the lower the pH is going to be, and it's going to be more acidic. If we add more carbon dioxide, more of it's going to move in, and we're going to have more of this hydrogen ion, and we're going to have a lower pH. Now, the levels of each of these can change. Each of these are reversible reactions, so depending on the amount of carbon dioxide, it can move towards the left or it can move towards the right. Why is this a big deal? Well, life exists in this water, and life is regulated by proteins, and proteins require a specific pH. So studies are showing that if we decrease the pH and make it more acidic, organisms are having a decrease in metabolism and they can have a decrease in their immune response as well. Now, how much of a change in pH are we seeing? If we look at pre-industrial levels, the pH of the oceans was really basic, 8.25. Post-industrialization, it had changed to 8.14. Now, there are going to be regional differences you can see on this map right here. And you might say that's not much of a change in pH, 0.11, but remember this is a log scale. So that represents a 30% change in the pH. What's it going to look like in the future? Well, as we play those models out into the future, by 2100, it could be as low as 7.80. Now, this low pH is going to devastate ecosystems for a different reason. This last carbon compound of the three is carbonate. That combines with calcium to form calcium carbonate. That's what the shell is made up of. That's what the bulk of a coral reef is made up of. And as we change the pH, we can change the level of that carbonate. What determines the concentration of these three? Well, it's going to be the temperature of the ocean water, the alkalinity, but also the pH. And so we can use a Jerome plot to figure out what's going to happen over time. These are log scales of the concentration of these three compounds. The green represents the amount of carbonic acid, the red line represents the amount of bicarbonate, and then the black line represents the amount of carbonate. Remember, that's important for shells. And so if we look at it at acidic levels, carbonic acid is going to dominate. At neutral levels, bicarbonate is going to dominate. And then at basic levels, those that we would find in the ocean, carbonate is going to dominate. But this blue area represents what's going to happen as we change the pH. And as we decrease the pH, you can see what's going on. The carbonate levels are going to drop off and the bicarbonate levels are going to increase. That's because that free hydrogen is competing with the shellfish, really. The free hydrogen is competing with that calcium carbonate to form more bicarbonate. And so now shells can't make their shells. If we look at what could happen over time, this is a pteropod shell at 7.8 pH. It is literally going to dissolve. And so if we look at, for example, coral reefs, they're getting hit with a double whammy. We've got global warming, an increase in the temperature is going to cause them to bleach or kick out all of their algae. I'll talk about that in a different video. But this ocean acidification is going to take that carbonate, and so they can literally not build more of the coral reef. And so these two things work together. What's the good part of global warming and ocean acidification? If there is a silver lining, it's they both have the same cause. It's increases in the amount of carbon dioxide. If we can decrease the amount of carbon dioxide, we can cool off our planet, and we can also slow down this ocean acidification. I wanted to thank Rebecca Blake. She put this out as an idea of a video that I can.
So what the video explaining is that the pH scale is what is used to measure acidity. He's saying that fresh water is around about 7 on the pH scale, which is right in the middle. When you add CO2, the water becomes more acidic. Our ocean creatures can only function and live within a certain pH level. Shellfish has an even lower tolerance for survival when the ocean becomes more toxic and acidic, it even makes them it's worse for them to even survive there. So if we continue with pollution, introducing carbon dioxide into the ocean, then the animals will start to die off. So how the food web is affected and connected to biotic bonds and chemical bonds is that shellfish are considered a keystone species organism that an ecosystem depends on in order to function. When shellfish populations decrease, the food web begins to collapse. Species such as the Atlantic cod, salmon, pollock, squid, and coastal waterbirds will lose a primary food source, and their populations will also begin to decrease. How this relates to the biotic balance is that the shellfish are what keeps the biotic balance in check, since it's one of the primaries in the food web is known as a biotic factor. Shellfish are known as a biotic factor since they interact and easily change with the ecosystem. Since the amount of shellfish is decreasing, the biotic balance has been thrown off, changing the whole ecosystem for the worse. Ocean acidification is a chemical change that is affecting the chemical balance in the ocean. As our ocean becomes more acidic, shelled organisms like oysters, zooplankton, and tetrapods have difficulty forming their hard exterior shells, which can lead to a decrease in their populations. When populations of shelled organisms begin to decline, food for dependent species also begin to decline. Examples how the economy will also suffer is that the loss of these species will threaten thousands of New Englanders who rely on shellfish for their livelihoods. With the value of the New England shellfish industry totaling to 440 million a year, Massachusetts cannot afford to lose these precious supplies. How ocean acidification and climate change relate is that ocean acidification and climate change are known as twins because they are both increasing the amount of carbon dioxide. So people need to work on trying to cool down the planet and create less carbon dioxide because, as you can see, there are multiple ways carbon dioxide is being released and affecting the planet. How humans can take action is that the biggest one we need to do is reduce fossil fuels, reduce the amount of energy we use, drive less, and donate to organizations that are trying to help the decrease of ocean acidification or increasing the amount of shellfish. So some organizations I found was Ocean Conservancy and IWJOA, which help with the decrease of ocean acidification. So you should go check out the programs they have there, or if they have any like donation areas. Thank you for listening to my presentation. And here are my tips.